Given an array nums containing n distinct numbers in the range of 0 to n inclusive, we need to return the only number in the range that is missing from the array. For example, if nums has 3 elements which are 3, 0, and 1, then we need to return 2, since 2 is the only number missing from the range 0 to 3. Since we don't care about the order of the numbers and only want to find the missing number, one way we could do this is to convert the list of nums into a set. Then for each number in the full range, we check if that number is missing from the set. For example, 0 is not missing from the set, and neither is 1. Once we find the number that is missing, which is 2, we can just return that number. Each set lookup runs in O of 1 time, and we must do this for each number in the full range, so this runs in O of n time. This is pretty good, but the problem is that the set will always contain n elements, which means this also runs in O of n space. We can actually get it down to O of 1 space by just calculating the sums of the nums array and the full range. Since there's only one number missing from the range, the sum of the total range minus the sum of all the elements in nums will give you the missing number. The code looks something like this. If n is the length of nums, then we can actually calculate the sum of the full range using a closed form formula. So 3 times 4 is 12, and 12 floor divided by 2 is 6. You could also do this by just generating all the numbers in the range and adding them up, but this is a small optimization that eliminates one pass of the full range. Either way though, the algorithm still runs in O of n time, because next, we have to calculate the sum of nums, which has to iterate through the entire array and get the sum of 4. Then we can just return 6 minus 4, which is 2, and we're done. Since we didn't have to create a full set full of n+1 elements, this runs in O of 1 space. This is probably the best and the most straightforward way to solve this, but if you want to get fancier, you can also solve this using Bitwise XOR. So first, let's do a recap on what Bitwise XOR is. XOR stands for exclusive OR, and when we use this on binary digits, it returns a 1 only if both digits are different from each other. Otherwise, the result is a 0. For example, if we XOR these two numbers, these two digits are both 1s, so the result is a 0. These two digits are different from each other, so that results in a 1, and it's the same with these two numbers as well. Finally, these are both zeros, so the result here is a 0. The reason why XOR is useful in solving this problem is because of two key properties that XOR has. First, if you XOR a number with itself, the result is always 0. In other words, the number cancels itself out. Second, if you XOR any number with 0, then you always get the original number back. So going back to the problem, what if we XOR all the numbers in both the array and the full range, and kept a running total of the result? Well, 3 XOR 3 equals 0 since they're the same number. 0 XOR 0 is also 0, and 1 XOR 1 is 0. Notice that 2 is the only non-zero number left, and so all these zeros XOR with 0 are still 0, and then 0 XOR 2 equals 2. And we got our answer, since all of the duplicate numbers canceled themselves out. Now the question is, will this still work even if you don't XOR those numbers in that order? The answer is yes, because XOR is both commutative and associative, meaning that A XOR B is equal to B XOR A, and A XOR B then XOR C is equal to A XOR B XOR C. So no matter what order we XOR all those numbers together, the duplicates will always cancel themselves out and we'll be left with the missing number. Now let's look at the code. Missing will be the variable that holds the missing number at the end, and we'll initialize it to 0. Traversing the nums array first, 0 XOR 3 is 3, so missing becomes 3. 3 XOR 0 is still 3, and 3 XOR 1 is 2. Then let's traverse each number in the full range. 2 XOR 0 is 2, 2 XOR 1 is 3, 3 XOR 2 is 1, and finally, 1 XOR 3 is 2. Now that the missing number has the correct final value, we can just return it and we're done.